Welcome, everyone. I hope you are doing well. Thank you very much for joining us today. My name is Marian, and I'm an international marketing specialist at the University of Tartu. I am very happy to welcome you to the Alumni Talks 2023 event, and I will be your host today. So Alumni Talks is our new series where our fantastic alumni share their story of studying at the University of Tartu, and they will give a short lecture on a topic they chose. So today I am here with Antonio, who is from Mexico and has lived in Estonia for the last 10 years. He has a master's degree in applied measurement sciences from the University of Tartu, and he works as a laboratory manager for AQ Lasertool, which is a metal manufacturing company in the automotive industry. And today his topic is a laboratory manager in the automotive industry. And just a little housekeeping before we get started. If you have any questions during the webinar, please leave them to the Q&A box, and we will address them at the end of the webinar. If you have any technical difficulties, please write us in the chat box and we will try to help you resolve them. And also we are recording today's talk, and all participants will receive a recording after the webinar. But now, without further ado, I would like to give a floor to our presenter today. So Antonio, if you're ready, you can start.
Sure, thank you very much for the introduction. Does everybody see the presentation, or?
Yes, you can put it on full screen.
There we go.
Yes.
All right, perfect. So yeah, thank you very much for the invitation. I mean, from you and from the University of Tartu. Like I studied, as you mentioned, applied measurement sciences. Very nice program, very good, like rounded up across the board. And I finished in 2020, summer of 2020. So it's been already a couple of years. So I'm very glad to talk a little bit about my experience as well as my professional experience. Yeah. So I'm going to be talking about the surface treatment in the automotive industry. So first of all, as I mentioned, like I studied applied measurement sciences in the University of Tartu. I've been living in Estonia for the last 10 years almost. February now is going to be full 10 years. So it got to a point where I was just looking for a master's. I wanted to continue studying. I was looking for different programs, and the one that had like the most appealing and the best option for my interest, in my opinion, was the University of Tartu, and I found this applied measurement science program. I was lucky enough to be able to be working and studying at the same time. Like I wouldn't say, I mean, it's not something that I would recommend people to do, like, but it's at least good to know that that is doable, or that there's options, right? I mean, as I mentioned, I was fortunate enough that from my work, they gave me the opportunity to be away for 2 or 3 days a week in the beginning and the first couple of semesters, and also from the University of Tartu, that you know, I could manage my schedule in a way that I could cover most of the credits how they were supposed to be taken, right? So again, like it wasn't easy, but it's doable. If you end up in that situation, at least you know that you know the possibility is there. It's not that you have to choose one or the other. So as I mentioned, like I worked already in my current position before starting the master's program, but still the master's program like gave me a lot of different skills, or you know, widened a little bit like the horizon of the possibilities of the technologies, techniques, or things around all that. Like I'm going to be talking a lot about only the automotive industry, but I just want you to know that that is one very particular case of so many different possibilities that you can do with all these measurement skills, techniques, and technologies. So as I mentioned, I work in the automotive industry, but it can be applied for pharmaceutical or for I don't know, research for I don't know, the food industry. You know, like literally the sky's the limit. So the whole point of all these techniques was like, if we can measure something in something, there's most likely a technique that allows us to do that, depending on what is our purpose of, or what is exactly what we want to measure. There must be a suitable technique for it. So to start talking a little bit about what I do, surface treatment is basically the term used for whenever we're preparing a surface. In this particular case, we're talking about metal. So we're going to have like a pre-treatment first that is going to prepare the surface for the additional layers that are going to be coating our material. Then it's going to come the e-coating or electro-coating. That is an electro-depositing process. We're going to get into it. And then the top coat, which is the powder painting. That one is, I mean, it's important, but it's not going to be like the main the main topic of discussion. And at the end, I'm just going to give you like a little rundown of what are my responsibilities as a laboratory manager in this industry, like for you to get a little bit of an idea of what tasks or what things you have to take care of if you end up in something similar, or I mean, just as a laboratory manager, maybe. So to start with, as I mentioned, surface treatment is, you know, when we're preparing a surface, in this particular case, metal, of any type. I mean, in our company, we deal mainly with hot rolled and cold rolled steel, but it can be, you know, zinc, or it can be copper, or like whatever metallic surface. There's gonna be, of course, different technologies that will be suitable for different metals. So, but they are like, you know, from the most tiny nut or bolt up to a fancy car, or, you know, all the signs that we see on the streets or on the highways. Pretty much every single metal that you can find around your house or around you has gone through some sort of surface treatment. And I mean, as I mentioned, there are so many different like technologies that are applied for this. There's electroplating, there's anodizing, phosphating, etching. You know, there's almost an endless list of different systems that they are called, or different technologies that you can apply in combination, depending on what are your what is your target, what are your the quality that you're achieving for it. So it's just as choosing the right tool for the right job. It's not that we don't want to do over quality for something that doesn't really require that much protection, and at the same time we don't want to get into the short end, just make a little bit of surface treatment where it's something that actually requires a lot more protection. Yeah. So all these, we're going to be focusing a little bit more on phosphating, which is the surface treatment that I take care of. So that is the technology that I'm most familiar with. And all of this is basically to stop corrosion. Actually, we cannot stop corrosion. The only thing we can do is to delay it as much as possible. And that's why all the different type of processes that we can utilize, depending on how long we can or we want to delay this corrosion. So as I said, like it's impossible to stop corrosion, but what we want is to delay it. So the applications will be just all metal surfaces that we're gonna surface treat. We just want them to last as long as possible, and for achieving that, we need to delay the corrosion. This actually also has another aesthetic application. It can, depending on the top coat or depending on the technology and the requirements that you need. And is for mainly for outdoors exposition. So as I work in the automotive industry, I mean, cars go in all over, you know, all over the world in all types of environments with a lot of humidity, a lot of heat, a lot of cold. snow, salt on the streets, you know, so the surface treatment composition or system that we choose must be able to protect us against all of that range of temperatures and environments. So our process flow basically starts with a pretreatment, which where the main core or like the most functional part of it will be the phosphating. We will get into that one. Then we will have the electrocoating, which is just a cathodic process. And then the powder painting. This is what I meant by you need to choose the right system of surface treatment that you want for the right job. For something that doesn't require that much, let's say, quality or that much protection, you might get away only by choosing the first two, like only a pre-treatment and e-coating, and skip the powder coating. Or if you don't need that tough of a protection, but you still need a top coat, you maybe skip the e-coating and you do pre-treatment and powder painting, depending on the product that we're talking about, or depending on the environment where that product is going to be utilized. If it's going to be also, for example, indoors, let's say, for example, hospital beds. Hospital beds are not really outside, you know, at minus 20 degrees with snow, but they also require some protection because the hospitals are very often sanitized, you know, so there's moisture involved also, so they need some protection. I mean, just to give another example. So to start with the pretreatment, it's going to be composed mainly by well, different stages, of course. We're going to have first our degreasing stages, which in our case are two different stages that together, let's say, make the cleaning stations. Some rinses, then what is called a conditioner, then it's going to come the zinc phosphating bath, more rinses, then it's called the seal rinse or passivation stage, and then a demineralized water rinse. This is how it looks. I mean, there's different ways of laying out this process, but in our case, it's basically 15 different tanks with transporters that just move the articles or the products from one stage to the next, and each stage has its own different parameters and purposes for, in all combination, making this surface treatment system that we're looking for. Starting then, first things first, with the degreaser. We received the metallic components. Actually, the metallic components are also manufactured here in Estonia, just in a plant in Pärnu for the most part. And the degreaser's purpose, what it's going to do is just to remove any oil or any grease or any dust or particles that are on our products that we want to protect. It can be just, you know, out of being outside in the environment, or because of the manufacturing process, you know, where very heavy oil greases are used as lubricants for the deep forming processes, or I don't know, you know, it can be also welding, or, you know, there's a whole lot of different impurities that we consider impurities for our process that can mess up our surface treatment. So what we want is to get rid of everything that is not the metal surface itself. So for that, then the degreaser will provide us with a water break free surface. So this is like just an example of when we have some contaminants or some impurities still on the surface, then the droplets of water will break. We want a uniform layer, which will mean that our surface is completely free of any impurities that will interfere with the surface treatment process. Yeah. Then we got 3 rinses. These ones are mainly just to remove the excess of the degreaser solution, because we don't want, if we really quickly go back here to the main, this one, we don't want any of the solutions or any of the different components of each bath to travel down the road to other baths. Some of them actually make some very nasty reactions that will maybe block your filtration pumps or your your circulation pumps or your filters, and something that you really want to avoid. So that's the whole point of the rinses, to create these buffer zones that will just remove anything that doesn't belong down the road in the process line. And also it removes the chemicals or the solution that is left over on the parts, because not all the parts are very simple. Like some of them have like a lot of different shapes or tubes or places where some of that solution can actually collect. And then you have what we call like drag out of the solution. So we want to minimize that as much as possible, push it back to the stages where it belongs. So in this particular rinse, what we don't want is to contaminate the phosphate solution that comes like 2 stages later. Yeah. Then we have the conditioner, or what we call the activation. This one works very closely together with the zinc phosphate stage, because what it's going to do is going to activate the surface. How it will activate it is basically because once we have our clean surface, metal surface, after the degreasing stages and the rinses, is going to deposit some salts where the zinc phosphate crystals can start actually growing. So that will give us like a very uniform, very smooth crystal structure. If we would skip this one and we will just go straight into the phosphate, that is the next stage, for example, the reaction will still happen. We still have the clean surface layer there, but the zinc crystal layer won't grow as uniform. It will be like a bit more accidental. And again, depending on the corrosion resistance that you're looking for, that might be already like a failure point or like a weak point for corrosion to start acting in your product. So basically what we want is, if we imagine that our clean metal surface is the surface of a pool, it's easier for us to cover it, if you just put some balls on top of it, and that would be our zinc crystals. But then what is easier to do to cover the surface, or not easier, but what covers the surface better? Big balls or slightly slower balls? I mean, if we have really big balls, or in this case crystals, the gaps between the crystals in a microscopic level, it's still somewhere where the moisture can penetrate and attack our surface that we don't. Again, the whole point of it is to isolate it so that we don't to delay corrosion. Yeah. So the smaller the crystals they are, the smaller the gaps between them, because they can cover better the surface to like as close as possible to 100% protection, coverage protection for the corrosion not to penetrate. So if we go even smaller in the size of crystals, then we will have like almost a foolproof layer that all the little gaps are going to be covered as much as this technology allows us to do. So for achieving that, of course, there's several parameters in these couple of stages, the conditioner activation and the phosphating bath, that will play a role in determining which type of crystals we're going to end up with. Yeah. So the zinc phosphate layer, as I mentioned, was, as I hinted in the beginning, is like the core stage for our corrosion protection. So what it's going to do is just going to delay it. Yeah. This is actually not really a painting coating, or it's not considered a painting coating, because different to with wet paints, or later on with the e-coat, as you will see, we're just going to add an extra layer that will basically isolate our material, but it's not really considered a painting coating or a painting technology, because it's not applied to the surface. What it's doing is actually chemically modifying the surface. So after this layer, what we're going to have exposed on the surface is going to be the zinc layer, no longer the iron or the steel. Yeah. So as I mentioned, there's going to be like different sizes and types of crystals that we're going to form because of the activation layer and the zinc phosphate layer. These are some scanning electron microscopes examples of it. This first one in the top left, you can still see the surface. I mean, there's some crystals here and there covering, but this tells us that there's a very, very poor coverage of the surface. Here, there's still very, very big gaps where if we have some moisture in contact with our products, corrosion will start spreading like a wildfire. Yeah. Next example, it's slightly better, still not perfect. We have like these like broad shape crystals, like little sticks. That okay, we have like a much better coverage overall, but because of the shape of the crystals, then we're not allowed really to cover the surface completely. Yeah, so there's still gaps where the corrosion can penetrate and start spraying. So, and this bottom example would be like as close as possible to like the ideal case that we have, as I hinted in the beginning, with the little balls covering the pool. So here we have like a nodular crystals that are very tightly packed into each other. We don't want them to be like very big in terms of you know, the microns of the crystals. They are like around 2 to 3 microns each crystal, and we want that layer to be fully covered with this type of crystals. So after that, we have the rinse, another rinse stage. This green one here is the phosphate stage. After, we have a couple of rinses, and it has a very similar function as the previous rinses. What we don't want is now the phosphate solution to travel down the road into the eco path or other stages down the road. We want to prevent that from contaminating other tanks. And also it removes the extra, you know, because it's a chemical process. What happens inside of that path, like there's some byproduct, which is the sludge, which is going to be basically iron phosphate that is generated because of this zinc layer forming on the metal. And we want to remove that sludge also, because otherwise it will interfere with the next layer on the system. Then we have a seal rinse or a passivation, which is basically after we already cleaned our surface, we activated, we put these initiation points where the crystals will start spreading around. Still, you know, even if the crystals are perfectly, you know, or ideally how we want them, in a very microscopic level, there's still some gaps between them. So the seal rinse, what it's going to do is basically stop the chemical reaction happening, because there's still going to be some droplets of our zinc phosphate solution there inside. And you might guess maybe, but if the zinc phosphate solution creates like this layer, why you don't leave it, I don't know, 5 minutes or 10 minutes there? The problem is, like, once our surface is covered, you know, and there's no more iron or steel for the zinc phosphate solution to do its job, it's going to start actually reacting on its own on the same zinc phosphate layer. And that will start not really destroying, but when you achieve this very nice uniform layer to protect against corrosion, and then you're going to start having some unevenness, some valleys or some hills that you don't want there. So that's the point of the passivation or the seal rinse, to stop this process to continue by just neutralizing and stopping that reaction that is still happening in a microscopic level with the droplets that were trapped there between the crystals. After that, we have like our last stage of the pre-treatment part. All this, since the degreaser is considered all pre-treatment line. So the demineralized water rinse is just basically our last chance to remove any dust that could have been you know, deposited on the part in the transportation of between the stages, and it will act as a safety belt for our eco tank, which is going to be the exact next stage. So it's all good and dandy that, you know, I'm telling you about all these you know, stages and how our process actually works, but the important part of it, and where the applied measurement sciences, let's say, has a role into it, is that there's a lot of parameters that need to be controlled in every stage. Not all stages are controlled with the same parameters. Zinc phosphate, for example, has much more parameters that need to be controlled and adjusted, as, for example, the rinsing stages. The rinsing stages, you just want them not to be, you know, with high concentration, and basically to have a fresh intake of water to have like a functional rinsing stage. So, but then all parameters can be, you know, from total and free acid or alkalinities, temperatures of the baths, pH, conductivities, how long you have the articles in that stage, meaning the process time, the circulation of the bath, you know. So like if let's put a quick example, if our cleaning stage is in a very good, you know, ideal concentration, the temperature is there, everything's fine, articles go in, and then there's no fresh solution like basically cleaning the parts because we don't have any circulation. Yeah, percentage of solids, for example, or how contaminated our part is. You know, if the degreaser is meant to remove the oil, I mean, the oil will start, the oil concentration will start rising in the bath if we don't do anything about it. So that's the whole point. It's just to exemplify that all these stages, so far 11 stages, they all have to be controlled and monitored for different critical parameters on each. And for that, for example, as I mentioned, the zinc phosphate is one of the most, let's say, convoluted. And there's something that is called a design of experiment that will allow you to basically identify which parameters are your critical ones, right? Because once you start having some maybe quality issues, it's very difficult to pinpoint, yes, it's because the degrees of this stage were like, I don't know, 5 degrees hotter or 5 degrees colder. So a design of experiment, what allows us to do is to take all the different parameters from the zinc phosphate solution, for example, in this case, which is agitation, free acidity, accelerator, pointage, like no point on describing all of them, but just to know that there's very many different parameters to control in that stage. What the design of experiment will give us information of is which of these parameters are the ones that had the biggest impact. Yeah. So maybe the temperature doesn't play that of a big role, or maybe the combination of two different parameters play a big role. You know, for example, if we increase the total acid and we increase the temperature, we will have the best type of, it's not the case, but just for an example, the perfect type of crystals. Or if we pull, you know, parameters here and there, like which combination of parameters are the ones that give us the best result. So that's where it's something like very time consuming, I would say, especially, for example, for the design of experiment in a process line like this, because you need to adjust all the parameters where you want them, and then just play with one parameter to increase, for example, the total acidity, and then see if that actually had an effect in your crystal layer. And you start like cross-linking all these different scenarios. So after all the pretreatment, whenever we're done with it, we are off to the electrocoating. The electrocoating basically is just going to be a like what it makes it is the E part is just that we require some electricity into it. Yeah. So the particles, the paint particles, are given an electrical charge. So we know positive, negative, opposites attract. We're going to charge the articles on a different charge, and then the paint is going to basically deposit on our parts, very, very diluted down. So there's two types. There's anodic electropainting or cathodic electropainting. We have cathodic electropainting, basically just how the technologies have been evolved. They started with anodic, but very quickly they discovered that cathodic was the way to go, that it has like a better corrosion performance. Yeah. And that is basically the E-coat path, how it looks when it's like not with the paint inside. On the sides we have the anodes. The part is going to go down. It's going to rest on these supports. It's going to close the circuit. The electricity starts running, and then that's how the paint particles are charged and deposited on our articles, on our parts that we are surface treating. So the advantages of the electrocoating is basically that it gives us like almost a full coverage, even if you think a very complicated part, because it's a dipping process. We're submerging the parts, then all around it is exposed to the liquid, to the paint. It has very good corrosion protection. It's a very economic or efficient process in the sense that everything that we feed into the system, like 99% of it will leave actually on the parts as film, as a layer that we are, you know, we want it to live there. We don't want anything to be waste or anything to be a byproduct, like in zinc phosphate tank that we have some sludge left over. Here in the e-coat bath, 99% of the chemicals or the products that you use are going to live on your articles. Yeah, and it has like a relatively low volatile organic compounds impact. The limitations of it, like if I'm telling you that the coat is like, wow, it's amazing, but not really, because the biggest drawback of it is that it's sensitive to UV light. So we would have like, our cars just e-coated, like after a week, the paint would be peeling off because of the exposure to the sun. So it's a really good base layer, but it cannot withstand the UV light. Yeah. Also, because of the bath looks like that, you might think, oh, okay, we can paint different colors, but it's very tricky to change the colors, and it's almost impossible. Well, not impossible, but it's very impractical and very costly. So most likely, if you want like a specific color for it for aesthetic reasons or whatever, you will have to build another line that will paint you that color. So it's not that this week we can paint black articles, like that is what we do. This is actually from our production line, and the next week we switch to pink or yellow or whatever. Yeah. So in the eco tank also, it also has its parameters that we control. Here, for example, the gravimetric analysis we use for checking the solids content, because even though it's like the paint tank, as we call it, still 85% of it is only the mineralized water. Yeah, and only the rest, the 15% is actually the resin and the pigment combined that makes the paint particles that will be attaching on our parts. So again, just another example of different things that we have to control now in another stage already in the e-coat bath, not in the pre-treatment. And to top it all off, to end, we have powder painting. The powder painting is just a free flow dry powder that is going to be applied electrostatically. Here we don't have any chemical like really processes. It's more physical processes. You just have to make sure that your conveyor line is grounded, so that you have the actual process happening there, and not the powder just falling off the parts. And basically what it's gonna provide is a really good, hard, strong finish on top of the parts. Yeah, and it will cover the biggest drawback of the e-coat, that is the UV exposition. Yeah, this one is resistant to the UV. We have it on top of the e-coat, so we have both layers, and our corrosion system, corrosion protection system, works as a compound, as a system. The advantages I mentioned already a few. This one you can choose different colors. This one is much more easier to just choose the color. 30 minutes, you change your whole system, you clean, and you can apply it on top of the e-coat. Not only the e-coat, but like the zinc phosphate is a really good primer for the e-coat, and the e-coat it's a really good primer for the powder. But this is again only our example. It's not the only surface treatment solution that exists. Mm-hmm. So a little bit about basically the job description of like being a laboratory manager. So there's very many different things that you have to take in consideration. Like not everything is just routine to check the baths and keep all the parameters in control. But okay, yeah. The first one is the process control, to make sure that all of our parameters are in line, so that we know that the production line is good to go, and is gonna have output of the good like a quality that we're targeting, depending on our customers' requirements, right? Then another part of it is the process verification. That means making like inter-laboratory analysis. That we don't do it every day, of course, but like on a monthly basis, we take a sample, let's say, for example, of the phosphating bath or of the e-coat bath, and then we measure in our laboratory the different parameters, and the sample we split into two. One we measure inside, and one we send to our suppliers of that chemistry, and then we compare the results to make sure that okay, the same result that we're getting of the concentration or pH or whatever, it's actually that one, right? As we have another laboratory giving similar or as close as possible results to make sure that we're on the right track. Then I don't know, doing laboratory instructions, the calibration of the equipment is also very important. I mean, that in those analyses is when you might figure out maybe you forgot to calibrate your instrument, or your instrument is failing, or something. If you send this sample to another laboratory and they come back with a different result that you get, is like, obviously there's something not matching there. Then of course, keeping inventory of all the chemicals. I mean, I'm sure if you're interested in this type of program, you have worked in a university laboratory, right? So all the reagents that you use for the different practices or for the different experiments, but basically in an industrial level. So all the chemicals that we need for building up the baths or for correcting the parameters in the baths. So to keep like a good inventory of it, to make sure that we're utilizing it's a FIFO system, which is first in, first out. You're utilizing the one that is basically the oldest in your inventory, not the one that just arrived, to avoid, you know, waste of, like, I don't know, that it gets expired or something like that. Of course, also the maintenance program. Like, I mean, not all the baths are, you know, you just adjust it and that's it. In many cases, we need to empty the bath, clean it, fill it up again, either with the same solution and adjust it, or to make a completely new solution. And our tanks are like 3.5, 3.6 cubic meters. Actually, it's quite small. There's a plant in Bulgaria that has like a quite bigger. I mean, it's part of our company, but they have 18 cubic meters per stage, not like 3.5 like we have. So again, it's just, instead of correcting with, I don't know, 2 liters that we do, they correct with 20 liters or something like that. And the process optimization. What we try to do also is like to narrow those parameters, yeah, as much as possible, that we know that we can still keep it under control. Since let's say, for example, here's total acidity of 24, right? That is our set point. We don't want to go okay, we're targeting 24, but our window is like from 0 to 50. Like, there's no really point. But if our limit will be also like 23 to 25, maybe it's too narrow, because the process itself, like, I mean, the production itself moves that one. So maybe it's too tight to adjust for us. So it's just to get that right fit for every parameter, to make sure that we're achieving, again, the right parameters for the quality that we want. So with that said, that's as much as I can share with you, just like that. And I would like to see if you have any questions.
Thank you so much, Antonio, for this exciting talk. And as you said, now it is time for some questions from our audience. And just a reminder, please type your questions to the Q&A box. And yes, I will start with the first one. So it says that, do you need to know Estonian language to study at the University of Tartu? And do you speak Estonian yourself?
I actually do speak Estonian myself, but I wouldn't say that play a role in my master's, because the whole program of applied measurement sciences is in English. So you really don't need I mean, I spoke with my thesis supervisor and with some people here and there in Estonian just to practice my Estonian, right? But for the purposes of the program, you don't really need Estonian. I mean, I wouldn't say that I'm a master in Estonian. That's way more difficult than the program itself. But but I do speak some Estonian, yeah.
Okay, thank you. So the next question is that, what made you get into the automotive industry?
To be honest, that was a little bit of an accident, I would say. Like, my bachelor is actually in biology, and that's how I ended up in, I mean, still science, you know. But when I arrived to Estonia, they just, when I applied for the job, I started there as a laboratory technician. They just needed someone with English and with experience in laboratory. So I was familiar with these processes, sorry, with these techniques, right? Like pH, titration, gravimetry, like different analysis. Not all of them, of course, but some of them. And the accident was that, you know, knowing those skills, they just I could never imagine that they were like applied in that sector or in that industry. So the fact that made me end up in automotive, like in the automotive industry, was by accident. I mean, the part that wasn't an accident was that I liked the laboratory work, and you know that.
Well, then it was a good accident.
Yeah, I guess. Yeah, so far so good. I can't complain, to be honest.
Okay, thank you. So the next question is, did you work while studying, and how manageable is it?
Yes, as I mentioned a little bit in the beginning, like I did it. I was working and studying at the same time. I was fortunate enough that from work, I mean, before I actually committed fully to doing the masters, I basically asked both the University of Tartu, saying, "Hey, is there a chance that I don't have to be there Monday to Friday? You know?" Yeah, there's a chance. I asked from work also, "Hey, there's this chance of me studying a master's, but that means that at least the first 2 semesters, you know, I'm not going to be here, I don't know, 2-3 days." Of course I had to keep up with work. That doesn't mean, you know, that I was on holidays half of a year. Sorry, half of the week. So it is possible, is doable. I did it. I wouldn't recommend it, but it is doable. I mean, if it's any help, or if anyone here interested ends up in that situation, what I was doing, because I live and work in Tallinn, so I was commuting a lot between Tallinn and Tartu. So very quickly I figured out that driving was not an option, because it was just 2.5 hours lost in my day. So I'd rather take the train and catch up with you know, I don't know, homework or articles to read or whatever, or I will catch up with my duties from work, you know. So yeah, I had to, especially the first 2 semesters, to split my week in half, to like half a week there, half a week here, and weekend to catch up as much as I could. But yeah, it's doable.
Well, I'm glad you managed to do it.
Thanks.
Okay, the next one is, how do you feel the program prepares you for the job market?
That's a good question, because as I mentioned, like I actually had this job already before I got into the program. But I think that the program actually does a really good job of, as I said, like exposing you to all these different techniques. You know, for example, one of that has the highest exposure is HPLC, right? I don't use chromatography at work at all, but at least now I know that skill. And if I would be to, I don't know, move to the, I don't know, food industry, let's say, and then they require someone with that knowledge, like the program makes a really good job in you know, exposing you to all those different techniques. And then where you end up working, you might use only 2 or 3 of those techniques, not all 12 or all 18, you know. So it's a like a good combination of, I mean, still is like a bit heavy-handed on the chemical part and not that much on the physical part, but there's also some, you know, physical techniques that you see. Yeah. So it prepares you in that way, that gives you all the base techniques without really telling you, well, it just mentions, it can be applied here and there, and you see some examples in the laboratory and in the practices, but that is, I would say, like just up to where you end up. So
Okay, thank you. So next question is, what is the most exciting thing about your job?
The most exciting thing about my job, to be honest, I think is the one that I feel I feel like having a very big responsibility, because we work really as a full company in the, I mean, let me explain. As I said, like the most of the parts that we also process, we also manufacture by the same company, not in our factory, but in Parno, for example. So you are part of an end product. Like our main customers are Volvo and Scania. So if there's a failure, it could have been on the surface treatment part. It could have been on the manufacturing part. It could be in the raw material part. Like you know, if my tanks or my process is complicated on its own, when you see the final end product, it's even more processes and more different variables that can affect that. So the I don't know, I guess I'm just curious by nature, and the troubleshooting part of it, you know, because I mean, measuring the temperature and keeping everything in order is, let's say, the easy part. But once you get like a quality claim or a defect that you have never seen, to start thinking or start researching, like, okay, what went wrong here? Can we replicate it? Like, do we have any idea what caused it, or in which stage it was, how we can avoid it in the future?
Okay, thank you. And let's take the next question. So you found a job before you actually graduated, but
Yeah.
What do you think? Is it hard to find a job in Estonia or even Europe after graduation? And do you have any tips?
Yes, probably. I mean, let me split the question in two. Like in Estonia, there's I would say there's a shortage of qualified people, like specialists, let's say. But at the same time, many companies require also Estonian language. So if you're working for a, I don't know, local manufacturer of chemicals, like they just expect you to know also the language, not only to have the like technical knowledge. In that sense, maybe, I don't know, it will just depend in which company you ended up. Like for me, as I said, like our company's actually headquarters are in Sweden, but because it has a global presence, like there's different factories all around Europe, and not only Europe, but all around the world, then the communication between all different teams it's in English. But if it would be only based in Estonia, then most likely, yeah, that would require also the Estonian. So I would say then the tips would be, if you're planning to stay in Estonia, like start learning Estonian so that you don't have that as a I don't know, drawback. And if not, then I mean, if I mean, as I said, I've been living here already many years, so like there has to be like a really good excuse that would make me move to another country or even back to Mexico. But if you're just aiming to finish the masters in Tartu, for example, and then go, I don't know, to Germany or something like that, like then I don't think that it's that complicated. I mean, in that sense, it will stick to like this a little bit international level. So with English and the skills, you should be good to go for applying for a position. So.
Okay, thank you. So next question is, do you have any tips for applying for this program? How did you prepare for applying?
That's what I was trying to think, like what did I do for applying? I mean, I was also fortunate that I got the stipendium, so that I didn't have to pay anything basically. But I don't know, probably at least on my particular case, what worried me the most was like the chemical part, because I mean, I know some chemistry, but I'm not a chemist by studies of my bachelor wasn't in chemistry. But fortunately enough, as I said, like, because it's like a little bit of everything, although it's a little bit heavy-handed towards the chemical part, that I don't know, in the requirements was not, they were a little bit more flexible in the sense like, okay, if you belong to, basically sciences, or you studied something related that you have some of the basic knowledge, they still allow you to apply, So I don't know, the tip would be maybe just like, play to your strengths. Like that doesn't mean that, my biological knowledge played a big role, no, but wherever I could use it, or wherever it could be come in handy, then, of course it was useful. So.
Okay, thank you. So the next question is, what were your favorite courses during studying?
Oh, that's a really good question, because there's one that, I mean, I think I would never end up in that part, but there was, I don't remember exactly the name of it, but there was one course that a professor from the United Kingdom came to give. Very short course. It was an option. It's not part of the mandatory ones, but it was about how do they utilize this, analysis techniques for DNA or for, you know, whatever in for solving criminal cases. So it was like forensic analysis or something like that. So it's something that I mean, I like, you know, to watch all these like criminal series or whatever. But, and again, I don't think that I would ever like work in that case. But again, the same way that I ended up in the automotive industry, someone with those skills, you know, if you have made, I don't know, DNA analysis your whole life, and then all of a sudden there's a chance for you to work in a forensic laboratory or something like that. So that one was definitely a highlight that I found it like so entertaining and so like eye-opening, the same way that I found it for the automotive industry, that you are familiar with these techniques, but you just don't imagine all the different applications that they have, you know. So that one, even if really just for curiosity, if you end up in this program, just take that class. It's really, really interesting.
That's great. I'm actually interested in that myself. So
there you go. Just take it out of curiosity. You don't need to know even the techniques. Like
seems like a good course. So thank you.
Mm-hmm.
Okay, so the next question is, what has made you stay in Estonia for so long?
Well, okay, yeah, I'm just gonna, I was going to go with a long explanation, but long story short, my wife is Estonian. I moved here because of her. And I mean, she had to finish her master's, then I found a job, then I started my master's, you know, like one thing has led to another. But I would basically summarize it as like, if we wouldn't be happy, or we wouldn't be living fine in Estonia, like we wouldn't still be here, you know. So what made me move here was my wife, of course, because she's Estonian. But what made me stay is, I mean, the country itself. It's a beautiful country. The only drawback is like right now the darker period, but you can get by through it. Like even many people complain about the winter, but me being from Mexico, I still find it exotic. So it's like it's a really comfortable, really nice, beautiful country to live in. So I don't know. To summarize, I came because of my wife, and I stayed because it's a beautiful country.
Well, I'm very glad you like it.
Thanks.
And you can like adjust to the darkness. So
yeah, or I mean, we normally try to go on holidays back to Mexico in that time. So you get rid of like 3 weeks of darkness.
Okay, I think we have time for one last question. So let's take this one. How was the teaching staff? Do you need Estonian for communication, or is English fine? And how was like the lecturers?
English is enough. All the teachers, you know, are, I mean, most of them are Estonians, and you could communicate with with them in Estonian if you know it. But everyone knows English, and everyone is very accessible. I mean, even if a teacher, you end up that, you know, they have 2 different courses, or they have, I don't know, many different theses that they're taking care of. And my point being, even if they are super busy, you know, they will take time to answer to you, or to take care of your worries. In that sense, like I cannot even think of like a class or a professor that you know, you write an email and you don't hear from them in a week or something like that. Like even if it's a quick answer of saying like, okay, thanks for your question, right now I can't, but I'll make the, you know, as soon as I can, I'll give you an answer. Like everyone is very approachable in that sense. Like quick email or a quick message through Skype or whatever, you know, and or even go to their cubicles, and if you are lucky and find them there, like no one is, you know, like, I know, outside of the teaching hours, I'm unreachable. Quite the opposite. I think everyone was like very clear in like, if you have any questions at any point, you know, shoot, and we'll do our best to answer as soon as possible.
Okay, thank you. That's very nice to hear. So, okay, great. I believe we have covered most of the questions from our audience. I would like to thank our presenter, Antonio, for sharing his experience and for a great talk on an interesting topic. And I wish you well in the automotive industry.
Thank you very much.
Yes, and thanks to our audience also for being with us today. So a few things before we wrap up. If you are a future student and planning to apply to Applied Measurement Science program this year, the application period has already started and the deadline is on 15 March. And also there is going to be a virtual meeting with the program director where you can ask any questions you have regarding the program. And we will also send you the information along with a recording of today's talk. So thank you again to everybody for joining us today. Especially thank you to Antonio. And yes, I wish you a nice evening.
Thank you very much. Have a nice evening to you too, and to everyone that is planning to apply. Like, even if you're a little bit interested, like go for it. I'm sure you won't regret it. Like, it's a great program. It's really good.
Thank you so much.
All right. Have a nice evening, everyone.
Okay, bye.
Bye.